Before I move into a brief explanation of Hypertime and my vision of Hypertime, I want to reiterate that astrotometry is a science. It is a science that I envision to be more rigorous than even the existing sciences. And so what is accepted as truth, or at least apparent truth, is going to be based on the ability to support the hypothesis with observations. Now, most of these observations in astrotometry are a paradigm shift. It's just a different way of looking at something we've looked at for, since we've been on the planet. And I think one of the big barriers to these movements is that we become comfortable with the way that we're viewing the world, with the way that we're understanding what the world is and the nature of reality, and we stop looking. We accept rather than challenge. And so that's the basis of astrotometry. And so the challenges that are brought about by the understanding of the nature of light, primarily, and the nature of matter, and the relationship between movement, light, energy, and matter are the fundamental driving force behind the theory. And so Hypertime is a way to understand better how things are moving. And I don't think that it's an abstract concept as much as it is a mechanism that we missed. Some things in astrotometry are abstractions. The chronodifferentiated motion, to a very large extent, is a practical abstraction. It's a way to practically engage the phenomenon of rotation and the phenomenon of spin on every level. But the Hypertime concept is a new mechanism that we had previously forgot about. And my impression of Hypertime came completely independent of all of the ancillary references that I found to similar concepts in a lot of the sacred texts. And so I'm not going to go into any of that on this channel. And if you're expecting that, you're going to have to check the other channel, Patterns in Chaos, or stay tuned on the Kosabi Institute for something that is the bridge between what would be the mystical metaphysics and physics. I think that that bridge may exist. But astrotometry is completely independent of that. Astrotometry is hard science. And so it's going to involve mathematics, it's going to involve a lot of calculations and measurements and scrutinizing, absolutely scrutinizing different types of observations and assumptions that we've made about the nature of space-time. And cosmology is a sort of philosophy on some level, because what is, in a sense, can't be separated from our perception of it. Our perception is embedded in what actually is. And this film strip concept is very popular in the quantum mechanical world because of the nature of a quanta, because of the uncertainty about where a particle will be, because it's a wave also. And so astrotometry resolves this with Hypertime. Hypertime resolves this. Hypertime has a model for how things are actually moving and how light gets these mysterious properties, how these mysterious properties manifest. And if you could imagine being inside the movie and trying to understand how the film strip is moving, that's the problem we're facing. That's the problem we're facing between perception and our universe, between our perception of the universe and how the universe actually is. Because we're, in a sense, all of our perceptual mechanisms are born out of it. And so without taking that perspective from the beginning in your philosophy, you can't expect to have a very accurate model of the nature of the universe. And so astrotometry factors this in. Astrotometry factors in that the device that is observing the universe is part of it. and inseparable from it, necessarily. And so the in that sense, it's the beginning of what would be a sort of non-dual science, but that's not the purpose of it. That's not the purpose of astrotometry. The goal is to resolve these conflicts. The goal is to understand things on levels that enable our working and managing our world. And so Hypertime is one of those ways. It's a new way to understand what's happening on a level that is underneath of the photon. Basically, the theory is in astrotometry that the photon itself is a standing wave. In other words, it's what I mean by a standing wave. I don't just mean that there's a string between one point and another, and there's a vibration. What I'm supposing is that there's another waveform that's underneath of the photon that travels back and forth between the place the photon is perceived to be emitted and the place where it actually is absorbed and arrives. And so there's a link through time and space that manifests as the spin correlation and the entanglement of the photon, which is the spooky action at distance. And so that is explained immediately by this phenomenon. But what is more interesting about it is that what is communicated is actually the structure of our material world. And so the structure of our material world is being communicated from one moment to the next by this hypertime mechanism. And the reason I'm calling it hypertime, the reason I'm labeling it hypertime, is because it's in between times. And so sorting out what the actual geometry of the hypertime movement is a big part of astrotometry. But what hypertime implies about the light that's coming from the heavens and our relationship to it is sort of, it all falls out of this understanding of what is actually going on. That's the theory. Now, when I first came up with hypertime and when I first came up with astrotometry, it was just based on this underlying mechanical theory about how things might be moving. It was basically an explanation for entanglement. It was a way to explain quantum entanglement and spin correlation and that kind of thing. Electromagnetic induction is easy to model with hypertime. Gravity is easy to model with hypertime. You can model these things. They become understandable phenomenon that the theory enables a way to work with these things in a way that is previously not been accessible. And so that's the theory. But since then, I've made observations based on the mechanics of what would be celestial interactions. In other words, astronomical observations that are very consistent, very expected, predicted by the theory of hypertime. And so it's kind of been, at some point I'm going to detail what those are. When I came into it, I didn't really have new experimental evidence for it. At this point I do. And so that's very exciting because it's basically resolving these other types of mysteries. And I just wanted to go ahead and say all this, and I hope that clears up some things about hypertime. And if there's more questions about it, please just comment, and I will address them as I can. Thanks. Bye.